Class, now we're going to chapter 2, matrix algebra. So first we're going to introduce matrix operations in section 2.1. All right, so some of the operations in matrix involving multiplication, additions, and so on. Before we do that, let's go get familiar with some terminology. All right. So if A is M by N matrix, so the M right here, the M is how many rows you have, N is how many columns you have. So a matrix with M rows and N columns. Then the scalar entry in the ith row and the jth column is denoted by Aij. So the first one is the row you will add. The second one is the column you will add. So you can see this one right here. Okay, so this is a row I, column J. Right. So each one can have a subscript to describe where they are. So for example, A1N is the first row, the nth column. All right. AMJ is the nth row and the jth column. So the columns are denoted by A1, A2, and so on. And that matrix A is written in such a way in terms of columns vector. So all these are columns. A1, A2, and AN are columns. And the number A sub Ij is jth entry from the top of the jth, well, ith entry from the top of the jth column, right? Vector A sub j. Right. So again, this is the jth column in the ith row. So what is diagonal entries in the n by n matrix? Well, we usually use this like representing A sub ij, represent the how many rows and columns we might have. However, the diagonal entry meaning A11, A22, A23, right here. So these are the diagonal entry. Okay, so it's called the so-called main diagonal. So diagonal matrix is a sequence of n by n matrix whose non-diagonal value are zeros. So let's look at n by n. So n by n, on the diagonal line you have all numbers. In fact, it's identity matrix, meaning they're all one and all the rest of the value are zeros. So let's introduce what's a sums and scalar multiple. All right, so if matrix, all entries are zero, we call it a zero matrix. All right, and it's written as zero. The two matrices are equal if they have the same size, same number of rows and same number of columns, and if their corresponding columns are equal. So what does that mean? So here, if A, B, C, D equals to 2, 11, negative 9, and smiling face, that just means A is what? A is 2, B is 11, C is negative 9, and D is what? Smiling face. And the sum is what? Adding the corresponding entry together. Okay, the sum is just adding the corresponding entry together. All right. And the scalar multiplication is simply to distribute the scalar to every single entry. Let's look at an example here. You have A and B. So before you add them together, you have to make sure they have what? The same dimension. This is 2 by 3 and this is 2 by 3. So you can add them. So add entry wise. All right. So A plus B is, you can look at here, A plus B is a 4 plus 1, you get 5. And 0 plus 1, you get 1. Finally, 5 plus 1, you get 6. All right, the other entry value follows through as well. Okay. Right, you cannot add A and C. Why is that? Because A and C are not the same size. So if R is a scalar and A is a matrix, then the scalar multiple RA is a matrix whose columns are R times the corresponding one. All right. All right. So some algebraic rule works in numbers. For example, commutative property work, A plus B equal to B plus A, and following. All right. Associated property work, the additive identity 0, so A plus 0 matrix equal to A itself, and distributive party work as well. Okay, same thing. All right, associated party work as well. All right. So each quantity in theorem A is verified by showing the matrix on the left side is equal to the same as the right hand side.